Hey guys, it's Andre from the High Performance Academy. I'd like to welcome you to Tuner Life, the show that keeps your finger on the pulse of what's the latest and greatest in the tuning world and who the top tuners are out there. We're coming to you live from Sema in Las Vegas. Sema's the biggest car show of the automotive year, and it's a perfect place to showcase the latest products, the latest cars, and catch up with the smartest people in the tuning industry. This show is brought to you by Link Engine Management. You can check out their latest range of Link G4 Plus ECUs at linkecu.com. We're brought to you thanks to the GT channel. For the latest and greatest automotive videos, make sure you subscribe to their channel. If you like what you hear and you want to keep your finger on the pulse, make sure you subscribe to our channel. Search for Learn to Tune on YouTube. Our show tonight's going to include two guests. We've got Bisi here from Bisi Moto Engineering, and we've also got Ryan from Rywire. So we're going to have a chat to these two guys a little bit later on. And first of all, we're going to move on to tuner news and talk about some of the latest products that we've found at Sema. First up, we have AEM's water methanol injection kit. Now, while their water methanol injection kit isn't exactly new, it's been around for a little while, for 2013 they have put a few new twists on it. Water methanol injection is a technique to help cool your combustion charge, basically allowing you to run more boost or more compression on a normal pump fuel. One of the biggest problems with water methanol injection is often it's impossible for the driver to know when you've run out of water methanol. This can be really dangerous. AEM addressed this with some really cool safety features, such as a water level sensor that tells you when the system is out of water. For 2013, they've also adjusted their system so it now can use an external map sensor, or you can take input from either a MAF sensor or a throttle position sensor. This allows their new kit to be used on a naturally aspirated high compression engine as well as turbocharged engines. Next up, we've got Innovate Motorsport's new electronic boost controller. Now this is a really cool device. It's brand new to the market at the moment, and it also incorporates their wideband controller technology as well. So you've got an electronic boost controller with a built-in wideband controller. The wideband controller uses their new direct digital technology, exactly the same as what's in their brand new LC2. Now the electronic boost controller is a really nice simple device. It's all housed in a simple gauge, and it can be all programmed through the gauge without the need to interface with the laptop. One of the really cool features I like with this new Innovate boost controller is the safety features. Now what it can do, because you've got a wideband controller built into it, it can monitor your air-fuel ratio, and you can set up a boost cut based on air-fuel ratio. So that'll help you protect your engine, avoid overboosting if you're running lean. It can also output a signal to an ECU or a data logger for the wideband signal. Next up, we've got the Zetronics ECA2. Now, Zetronics are already well known for their existing ethanol content analyzer. It's a product that's already won 2 SEMA awards. Now, their existing ethanol content analyzer is used to take signal from an ethanol content sensor and display a content of ethanol so the driver or the tuner can see that. It's being used mainly these days for interfacing with an aftermarket ECU for flex fuel compatibility. So this takes the ethanol content sensor signal and sends it out to an ECU or a data logger. Now a lot of people were using that, so they didn't need the functionality of a visual display of ethanol content. For this reason, Zetronics now have made up their ECA2. It's a slightly cheaper product, does all the same things that the ECA1 did so well, and this time it removes the visual display, so that's how they managed to make a slightly cheaper product. Still gives you that signal that you can interface with your ECU, perfect for flex fuel systems. Lastly, we've got the NOC-Link product. Now this isn't exactly new to market, but we wanted to showcase it here. Now the NOC-Link product is used for a visual display of knock or detonation. Now, knock or detonation, that's the number one biggest killer of any performance engine, and with loud exhaust systems, maybe wastegates that are dumping to atmosphere, it can be really hard for the driver or the tuner to audibly hear detonation occurring inside the engine. The NOC-Link product interfaces with a factory knock sensor, and it will give you a visual indication if knock or detonation is occurring through a high intensity LED light. One of the really great features with the NOC-Link is it's so simple to set up. It self-calibrates using digital technology, so you don't actually have to do anything yourself. It's been proven to be highly accurate in sensing detonation. It's a very small product, easy to package in your car, and it's really well priced. Now, while we were at SEMA, we caught up with Bisi from Bisi Moto, and he gave us a bit of a tech tour of his insane Honda Odyssey wagon. So let's go and have a look at all the details with Bisi. Hey guys, it's Andre from the High Performance Academy. We're here with Bisi from Bisi Moto Engineering to talk about his insane Honda Odyssey wagon. So Bisi, this car is amazing. We want to just get a little bit of a spec list going of what you've done to it. So can we start with the engine? What have you done there?
It's a J35 power plant from Honda, but I've done amazing things to it. The factory sleeves are ductile iron, impregnated in aluminum. Those are completely removed and replaced with a full ductile iron sleeve, which are also braced to prevent any kind of movement or whatnot at high boost pressures and high stress levels.
So we're talking about taking a naturally aspirated engine and you've turbocharged it. So okay.
My apologies. I went ahead of myself here. The engine is naturally aspirated, makes a whopping 250 horsepower. 206 to the wheels is what I saw on my dyno. However, we added a very large mid-frame turbocharger to it and reinforced internals significantly to be able to handle the power and handle the boost as well without any challenges whatsoever.
What brand of pistons and con rods are you using in it?
R&R connection rods, which are made of steel, and Arius pistons of our design, 9-to-1 compression.
What about head gasket integrity? Is that a problem in this engine?
None whatsoever. The head gasket from factory, being a multi-layer steel, is extremely robust. And we put them through the ringer. We have 1,000 horsepower inline 4-cylinder engines using the same factory MLS head gaskets. I employed the same technology from Honda in this engine as well.
Valve train, has anything changed there?
Significantly. The vehicle in the US market only comes as a 6-speed automatic. This 2014 Odyssey van really needed significant assistance in the drivetrain department. So we had some custom axles made in-house. Above and beyond that, the gearbox was removed, 6-speed, removed from an automatic perspective, and a manual gearbox was added from a 2008 Acura TL, which also comes from factory from Acura with a limited slip differential, with also a custom shifter as well, using some Honda parts and some parts fabricated in-house.
So this Honda Odyssey here, this never came out as a manual option, did it?
Never manual option in the US.
So this is the only one in the world that's got a 6-speed manual?
That is correct. Only one in the world, 6-speed manual of this generation, 2014.
Okay, let's talk about the cooling package on it. Intercooler, radiator, what have you done there?
Wow. We had a spherical turbonetics core brought in-house. Then we had to fabricate in-house the end tanks and be able to do something very, very interesting for the package to allow not only clearance for the hood, but also a very efficient flow so we don't have any turbulent type of flow in the intercooler itself. As you can imagine, when we do turbocharge and we compress the air, there's a significant amount of heat exchange that has to occur to keep things in check so we don't have any problems. The heat is generated in direct proportion to the compression. And to be able to eclipse the 25, 26 PSI mark, we have to have a very efficient bar and plate intercooler to be able to do that. And my team and I were able to put something together and design something that met that mark and kept the temperatures, intake temperatures in check.
Okay, getting an engine like that so modified to run well in a car, obviously the electronics is pretty important. What have you done there to keep everything running?
Well, as an advocate of the AEM EMS, I did elect the services of AEM once again to use an AEM Infinity ECU. The vehicle still stays full drive-by-wire, so I have full control of all the protocol for drive-by-wire. I even have the ability, if I so desire, to have different modes of sport, eco, and full-on normal mode if I desire. The traction control parameters in this, as you can imagine, being a front-wheel drive vehicle, can be a bit of a challenge. The AEM has a wonderful system, so easy to allow me to control traction and monitor front and rear wheel speeds and keep them within check by taking away power either by closing the throttle, using some type of ignition cut, using a fuel cut if need be, but fuel cuts tend to be a little bit hard to recover from. So I'm a huge advocate of TPS and also a soft ignition rev limit.
So with that traction control, how much power is it trying to hold to the ground?
This thing was designed to make 1,029 horsepower. That's the goal for this vehicle. It was designed for that. And that being said, with tires of this size, even with our compounds, it's going to be a bit of a challenge. But with the front and rear bias and the very simplistic way that AEM put a protocol together for traction control, it would be a breeze to have adhesion in any type of surface.
That's impressive.
Thank you very much. Thank you so much.
I noticed it's also got an aftermarket dash in there. Can you tell us a little bit about that?
Yes, the race pack dash is extremely, very nice. Has a very nice, elegant look to it, but has the ability via CAN control to have perfect communication with the AEM Infinity. So every parameter that the AEM sees, I can display on the dash. Everything from RPM to speed. I do have the dash that has a GPS built in, so I necessarily don't even need wheel speed sensors or gearbox sensors to know how fast I'm going. It can use a global positioning to be able to tell me my speed, which is very nice. Above and beyond that, other parameters like air temperature, water temperature, oil pressure, and get this, level of fuel in my tank also is a huge advantage of this system. So it's a very simple, intuitive system to use, plug and play per se, and one that I'm a huge advocate of as well.
The fuel level particularly is a really nice feature in any car you're going to run on the street.
Absolutely.
Okay, so looking at the car from the outside, it doesn't look like any Honda Odyssey I've ever seen before. What have you done with the suspension to get that ride height?
Well, you know what? It has a very beautiful stance, and I know stance is kind of a bad word sometimes in high motorsports circles, but I wanted a vehicle that not only could appeal to the enthusiasts who love cars from an engine perspective, but also people who love how certain cars look. The vanning culture in Japan is very big, and this pays homage to them. So I elected the services of air ride suspension to be able to create a unique bag system that is not available to the public for the 2014 and onwards Honda Odyssey. Above and beyond that, you can see these very nice wheels here from 1552. They're 20 by 9.5 in dimension, inches of course, and it gives a very nice look, very nice elegant look to the van itself as well.
Lastly, the interior looks like it's had a bit of work as well. There's really no area of this Honda Odyssey you haven't touched. What's been done to the interior?
You see, interior has a very nice supple leather interior with a very nice basket weave grain in the center of it. I wanted something that also, is very extremely fast and could appeal to enthusiasts, but something that could be luxurious for the family as well. I have a new family now, and I love speed, and I love power. And I want an opportunity where I can build a car that can really allow me to take my family out and have a great time and have enough space for all the kids' toys and so on and so forth, but also be fun to drive on the street and on the track as well.
Well, you've certainly got room for the family in the back, no doubt about that. And with 1,029 horsepower, I imagine that should be enough to keep the kids in the back pretty quiet.
Absolutely, absolutely. It's going to be a blast out there.
Okay, thanks a lot for taking the time to talk to us, BC.
Thank you.
If you've just joined us, you're watching Tuner Life. I'm Andre from the High Performance Academy. I'd like to thank Link Engine Management, our sponsor for today. You can check out their latest range of Link G4 Plus ECUs at linkecu.com. I also like to thank GT Channel for helping us out here. If you want to check out the latest and greatest automotive videos on the internet, make sure you subscribe to their channel. If you like what you're listening to, also make sure you subscribe to us. Check out Learn to Tune on YouTube. And if you want to learn more about EFI tuning technology, check out www.learntotune.com. Now, we've got BC here with us in the studio, and thanks for coming along, BC.
My pleasure.
Now, you're no stranger to import drag racing, you're no stranger to Hondas, but more importantly, you're the only tuner I've ever talked to who wears a bow tie. Tell us a little bit about that, and also your chemical engineering background.
Yes. Well, about the bow tie, it's just something I have this year. I like to think of myself as someone who brings a little style and elegance to the scene. So that being said, it's my new thing, just something different. Last year and the year before, I had this crazy blonde hair. This time it's a bow tie, always something exciting.
Cool.
But about the engineering, chemical engineering is a discipline that I decided to take upon when I was a youngster. And I came to the United States and finished up chemical engineering and got my master's in engineering management. And it's something that really is near and dear to my heart and allows me to be an exceptional tuner and engine designer as well.
So the chemical engineering, that came before your tuning career, correct?
Yes, it is. Yes, it did.
Okay, so it's an interesting mix, chemical engineering and tuning. Tell us how the chemical engineering background actually helps you out as a tuner.
I'd love to. As a matter of fact, if you think about chemical engineering and what chemical engineers do, they have the ability to design processes and plants that allow you to take raw materials and form useful finished product. So to be able to do that, you have to, of course, in a curriculum of engineering, you have to have a very strong background in electrical engineering, because most plants have, of course, electricity that runs all the critical components. You have to have a very strong background in civil engineering because, of course, structures are involved. In engineering management, because, of course, you don't want to build a plant that is very wasteful. You want something that's very efficient in terms of revenue and resources. You have to have a very strong background in chemistry, of course. And really the icing on the cake is some of the curriculums or disciplines we have to take away from the mechanical engineering department. Things like thermodynamics, fluid dynamics, mass and heat transfer. Those are key components from mechanical engineering that chemical engineers also absorb as well in their curriculum. So upon graduation, it gives a chemical engineer like myself a very strong, solid background. And hence, when I build engines, when I design engines, I take in consideration those key components that I learned.
Think about it. Andre, an engine is nothing but an energy converter.
Sure.
A chemical to heat to mechanical energy converter. Think of the chemicals involved in combustion, in an internal combustion engine. You have oxygen, which is contained in the air, about 21%. You have gasoline, or your fuel. Those are two key components that are chemical in nature. With combustion, you now create heat energy. That heat energy is now harnessed to be able to do work on the piston, which is now mechanical energy. So if you think of that as a closed system, I as a chemical engineer, I always do, and if you open up any of my engines, you see extensive use of treatments, surface treatments, coatings, or whatnot, to be able to harness that energy. What many of your viewers may not know is that almost 80%, 70 to 80% of the energy harnessed in combustion in engine is lost to the atmosphere. When you absorb that energy, whether it's energy, heat dissipation, or energy that's radiated away, if you can harness that and allow it to do work on the piston, you're now creating more horsepower. And that's what sets me apart from other tuners out there.
Yeah, I can see how, so an engineering degree, an engineering background, really, you're basically talking about everything that makes an engine work anyway. So
absolutely.
That is a big advantage to you over potentially other tuners.
Understood.
Okay, so let's look at your background in the automotive sense.
Yes.
So you came to the US from Nigeria.
Yes, that's correct.
You've got a chemical engineering degree. We've
Yes.
just talked about that.
Yes.
You're well known around the world for your exploits with the Honda brand.
Yes.
Tell me how you got into the Honda brand when you moved to the US. What made you choose Honda?
When I came to the US, it was very simple. As someone who loves to do research and read quite a bit, I wanted to be able, as a student, to have the most efficient and most reliable means of transportation. Even though I loved the look of the Pontiac Fiero then in the 90s, upon reading some reports in consumer reports or reviews in consumer reports, it didn't fare very well. However, there was one two-door vehicle that was very efficient, very lightweight, and had impeccable fuel economy, and that was the Honda CRX HF. I love the styling of it, of the second generation 88 Model Plus, and it was just absolutely a beautiful sight to behold. So that was the vehicle I ended up with. It was really from the influence of consumer reports that allowed me to pick up a CRX, and from then on, it was just amazing. It was just amazing love with Hondas.
So let me stop you right there.
Yes.
Now, you're into performance cars, you're a drag racer,
Yes.
You've got a lot of records to your name.
Yes.
Am I right in saying you chose the CRX because of its fuel economy?
Yes, that's correct.
Seems like an unusual connection.
It does, but initially as a student, I wanted something that could be economical for me. However, that proved to be extremely useful for me because that vehicle started as a lightweight chassis. So in my escapades or my exploits of being fast, it ended up being a very huge advantage for me indeed. And once again, in the late 90s, early 2000s, we didn't have access to a simple catalog or any aftermarket parts. We had to create our own. So being able to use my background to develop parts and design parts and do extremely well at the racetrack, with the influence of some of my peers in the engineering department and at work, I was able to have a very successful racing program, even though it's my only means of transportation.
Cool.
Thank you.
Now let's talk about the racing that you were involved in back then. Now, again, I mentioned you're a pioneer of drag racing
Yes.
and Hondas,
Yes.
and back then, you know, the sport compact scene, the import racing really wasn't well accepted. It was very much a domestic racing scene,
Yes.
and guys like us, we weren't really welcome at the
Very
racetrack.
true.
Now, that brings me to a somewhat taboo subject. Well, let's talk about street racing, because that's really where it was at back then. Is that where you cut your teeth in drag racing?
Yes, I did hold my teeth in drag racing on the streets of Los Angeles, on the streets near Los Angeles, Compton, Wilmington. And what really comes to mind is a very interesting event. I mean, it was a great way to complement resources for me. As a student, I worked full-time and went to school full-time, and even working at an electronics store, Circuit City, it didn't really provide me the resources to be able to get equipment and lab supplies, books, and so on and so forth. So I had to do something to be able to, make a lot of money, and street racing really fit the bill. It was a place where you can do fairly well if you win, and have some great street cred, to boot.
So it is actually a way of making a reasonable amount of money.
It was a way to make
And
a
when
reasonable
we say
money.
reasonable amount, sort of, what are we talking? We're talking $100 here.
That leads me to a perfect example. I remember, in the late 90s, I had an opportunity to receive a phone call from a fellow enthusiast who pretty much called me out for a race, and he wanted to race me for the title of the fastest single cam engine. So I said, okay. We got together, my team and I, and we went to a open strip in Wilmington, California. And it was amazing. When we arrived, it was just a small call. I mean, no internet craziness. It was just a small call. But when we got there were over 600 people there.
Wow.
Waiting to watch this race. The gentleman comes up to me. He won't mind if I mention his name, Tom Young. And he said, hey, we need to race and we'll make this happen. $5,000 right now.
$5,000.
$5,000. Now, I had like $90 in my pocket. I didn't expect to do a $5,000 race, and I don't think I ever saw $5,000 in one place at the same time.
That's
and
a
it's
serious
$5,000
amount of cash.
Yeah, $90 in the 90s. So it's not today's $5,000, but then. Well, what was interesting is that a gentleman who's now a very good friend of mine and a crew chief for my team, John Mitchell, came up to me and said, hey, what's going on? I told him, this guy wants to race me for $5,000. He reached in his pocket and put out $5,000 and gave me. So here you go. So I thanked him and embarked on the race. And what's interesting, once again, going to my engineering background, the other team, they were too busy doing burnouts. The guys were holding the fenders, pushing the car back and forth. And I, as a scientist, knew they were creating a lot of heat soak in the intake. So that didn't fare very well in terms of power. I just sat down, my car parked idling, just waiting for them to finish. And then we lined up. The gentleman who was staging us staged us. Hands went down. And out the hole, the guy just smoked me. Destroyed my car. Well, by second gear, I caught him. By third gear, I was a good 2 car lengths ahead of him. And by fourth gear, I won the race.
Wow.
So that being said, I won $5,000, which is amazing.
Yeah.
So I took all the winnings and gave to John. He said, no. I just took my $5,000. You can keep that. So that talks about the kind of money that we were making then. But then again, in those days, the street racing environment was a lot safer than nowadays. Ever since the movie came out, Fast and Furious, everyone with a vehicle felt like in street racing, people being very responsible. But then, not only we were responsible, we didn't really have a place to race. There were no sanctioned events or no tracks that were available to our disposal. So that was a way of life for us then. But nowadays, there's so many sanctioning bodies out there. There's so many outlets for us to race. And I really don't condone street racing at all.
I think the other thing to point out as well is, these days everyone's got access to cars which are much, much faster than the cars we had back then.
Very
so,
true.
that makes it a little bit more dangerous. And I don't think anyone's sitting here saying that street racing is okay, but it's definitely where the sport compact, the import racing scene has come from.
Absolutely.
And no one's going to deny that that's the case. Now, I'm just sitting here thinking, who rolls around in the 90s with $5,000 in their back pocket?
Understood.
That's some crazy cash.
He still hasn't shared with me where those resources came from, but he's a great guy. He's a great guy.
Good stuff. Okay, so moving on to the cars that you're best known for. And this is another thing I can't quite get my head around. I'm a turbocharged guy,
Understood.
That's the way I kind of like to go. And you kind of made your life really difficult. You went naturally aspirated.
Yes.
And not only that, you also went with the single cam engine. So let's talk about the challenges that put in front of you.
It wasn't by design. In the 90s, the hot thing then, just like the K-series swaps now in the Honda world, the B-series was a hot ticket then to do a B-series swap. And as a student, I could not afford $6,000 to do a B-series swap. So at the time, to swap in a larger B-series engine. So I took my knowledge and what my experiences and testing and stayed with the single cam engine. And as I noticed, even when I went to events, battle of imports started becoming very, very popular then, I started winning events. And not winning because I had the most powerful car there, because I was shy a good 40, 50, sometimes 60 horsepower, but my reaction times at the light allowed me to win quite a few races. And I also had the opportunity to have this feather on my cap where every event I entered, I qualified at least in the top 8. Perfect. So that being said, it was true testament to the technology I had access to then.
Actually, I'll stop you and we'll just talk a little bit about that, because I think that's another thing that the import racing scene is well known for. The guys are going out to try and prove something, and a lot of it comes down to people are racing for PB. They're racing for that time slip, and the reaction time doesn't matter. And really, when you're actually in a drag race, it's the person who crosses the finish line first that wins the race.
Absolutely.
So, and that's lost on a lot of guys. So really, that reaction time, that whole shot is so key, to a good drag racer. And obviously, you've got your game dialed in pretty well there.
I concur. So that being said, I was very successful with that, and it attracted, because I was always the underdog, and people always rooted for me. And even I remember some events I'd go to, like an IDRC event, and when my car pulls out, they play this cool African music, and it was just a great show. That being said, it created a lot of popularity for me. So even when I graduated from college, and had a great job in pharmaceutical research, I could afford any engine I wanted to. But I remember how great it was, how popular it was for me to have an underdog power plant. I remember not too long ago going to a junkyard and seeing the F22A engine. That's another single cam non-VTEC engine that existed in the 1990 plus Honda Accord. It was very similar in design and structure to my D series, but as you can imagine, as you know this, and many enthusiasts know this, the key to power is in the head.
Sure.
So looking at the D series versus this F series, the F series was this large power plant that was pretty much a D series grown up. Impeccable head ports, very similar to what you would see in the S2000. The exhaust ports are beautiful, almost similar to something you see in a B series. I pulled the head, floated, and I was amazed. The F head, the F series F22 non-VTEC head, flowed stock better than many ported B series heads.
Wow.
So that being said, the potential was amazing. In my D series, my D15 engine, I got it as fast in natural aspiration as 10.7.
Let's actually, before we move on,
Yeah.
now you were well known for your exploits with that single cam engine,
Yes.
and I believe you're the first person to run a 12-second pass,
Absolutely.
then an 11,
Yes.
then a 10,
Yes.
and then a 9.
Absolutely.
So you really were a pioneer back then.
Thank you. And above and beyond that, I did this with non-VTEC engines
Sure.
on petrol, and something that I'm very proud of is of all the cars out there. Natural aspirated cars. We've come a long way from when we started from the inception, but the 150 mile per hour mark was very difficult to eclipse. And I'm pleased to share with you and your viewership that my team, my vehicle, my Insight was the first natural aspirated car to hit 150. And it was amazing. And while my peers are doing 145, 146, I was doing 150, 151, 152. There's not one event I went to that didn't get protested.
Yeah.
People are broken down my engines to see what's going on. Do I have nitrous? Am I turbocharging? What's going on? But it's once again technology that allows me to make that kind of power and do it very well.
And for those out there who aren't really familiar with drag racing, that mile an hour, that's really the benchmark. That is the key because there's no dyno mimicking, there's no bullshit. It's all real, and that mile an hour with the weight of the car,
True testament of your
that is
power.
the true testament of how much power you're
Absolutely.
making.
Absolutely.
So yeah, that's a real feather in your cap there.
Thank you. And taking it back to, once again, the F series. So seeing this engine and pretty much mimicking everything I did with the D series, carburation, camshaft design, piston dome design, rod design, RPM, you name it, tuning capabilities. First time I went to the track at Carlsbad Raceway, my best time being 10.7. The first pass on the track, I did a 10.3.
10.3.
And
Wow.
I came back from the pits shaking because I never went that fast before. It was just amazing. Next pass, I hit a 10.29. And I was a 10.2. It was just amazing. And got a great article in D Sport because of it, cover article. And I was very, very proud. So it really was a true testament to technology and head flow and how you can really make some great power paying attention to detail. It was just phenomenal. I was so excited. So I stayed with that. I could have purchased any engine I wanted because I was a professional then.
Sure.
But the F Series just took that notoriety to greater heights and able to create a whole slew of parts for the populace as well.
And I mean, really, you were one of the few people that were developing parts for that platform
Absolutely.
as well.
Absolutely.
So it set you apart. So let's talk about modern technology
Okay.
coming in and EFI.
Yes.
So what sort of advantage have you seen from moving from carburation to EFI? And let's talk about that a little bit.
No, quite a few. The reason why I was carbureted back then is because, in the 90s, I had this HF engine in my CRX, and the HF is an 8-valve head, and I clearly knew the advantages of a 16-valve head. So I went to AEM. I met a gentleman, a proprietor by the name of John Conciaudi, and he was a great mentor and great influencer to my technology and my experience. And he shared with me, you need to take these injection out and put in, carburetor system, because we didn't have access to any, Hondata or any engine management systems at the time.
Sure.
We didn't know about wiring. I just knew that I needed to be able to convert this thing to a 16-valve head, and my factory ECU wouldn't control it. What we discovered is that I saw a 12% improvement in power compared to my peers who had standard, SI heads in my own CRX. And I had to determine why. Why is it that I made more power?
So that 12% increase in power, that came from the move from EFI back to carburation?
To carburation,
Wow.
absolutely. And performing an experiment in school really gave me that information. It gave me the opportunity to understand what was going on. I performed an experiment in school that almost got me expelled because it wasn't approved by the department chair. I went to our chemical engineering lab and I was very curious about optimization. I was able to mimic what happens in the engine. I had an intake manifold with standard injectors that we had access to then, and simulated what happened in the engine and saw the spray. The spray was a typical injector spray that you see in any OBD0 setup. And I noticed that the farther you moved away from the injector nozzle, the better you saw the spray pattern.
Yep.
The carburetor, on the other hand, being able to mimic what you see in vacuum in an engine, it was a beautiful cloud coming out. And then it hit me. As a chemical engineer, atomization of that fuel was key in creating power, key in being able to generate more heat to make more power for me. So that allowed me to be very, very successful with drag racing using carburation. However, you asked me about the advantages. Nowadays, we have improved injector systems.
Sure.
We have improved injectors, improved pintles, improved nozzles, and added with improved fuel pressure, we're able to mimic and even improve on optimization compared to what we see with carburation. As a matter of fact, if you look at my drag race setup now, you'll notice that I have stage injection.
Yep.
I have a port injector that's very close to the intake valves, and I have another stage injector, set of injectors that are farther away. And what I'm trying to do is mimic what I did with carburetors, if not improve on it.
And that's similar to what we see in current F1 engines. The
Absolutely.
injectors are mounted outside of the intake trumpets to get that atomization. So, talking about that engine, because I did spy that when we were walking around in your shop, and what kind of power improvement did you see from moving from the port injection out to an injector mounted in the intake trumpet?
For a 400 horsepower engine, similar to kind of power levels I was making then, I saw up to a 16-wheel horsepower, 12 to 16-wheel horsepower improvement.
That's a massive improvement.
That's very, very huge. And
it's hard to get that sort of improvement with a naturally
difficult.
aspirated engine.
You don't have to, nothing to do mechanically with the vehicle. It's just pure power from optimization. It's just phenomenal. And I'm sure it's everything from the particulate matter of the fuel to the cooling of the intake charge as it continues to go into the intake tract. It's just an amazing advantage.
Now, the importance of using that in a staged sort of system where you've got port injectors right down by the intake
Yes.
valve, plus the injectors outside of the intake trumpet.
Yes.
Talk to us about how that works. How do you use it through the ECU?
Great question. It's very important for me to share with your viewership that you should never use a faraway injector on its own.
Sure.
With larger camshafts that we have access to nowadays, with the massive overlap that occurs, you could get some reversion that occurs that can bring flames with it. It could be a very dangerous situation. What I have done using an engine management like AEM or any engine management that allows you to have any kind of stage injection control is at lower RPMs and lower speeds, you can have the port injectors supplying the fuel. As you continue to go up in RPM and loads, you can gradually turn those off, the primary injectors off, and wean in the stage injection. And then you'll see all the advantages that you need to be able to have a very successful system. And it works extremely well. And with proper tuning, it's a seamless transition.
So these are the sort of advances we can only really see with modern EFI.
Absolutely.
Those technologies weren't available back then when
Absolutely.
you first started out.
Yes, sir.
Okay, so now I want to move on. We've looked at the video of your Odyssey. There's a bit of a minivan theme or culture running
Yes.
through there. And you're really well known for your original Honda Shuttle. So
Yes.
let's talk a little bit about that car, because that thing's world famous.
The shuttle was very interesting. I'd love to be able to share with everyone, how that came to be. In 2008, Source Interlink, a very large conglomerate in terms of print media, put together this very interesting tuner shootout, and involved all what they observed as major tuners in the United States, and involved a variety of engine platforms. And the key was to make the most horsepower per liter reliably. This had to be a car or an engine that could cycle from peak horsepower to peak torque for 30 minutes straight. So, that being said, I was solicited to represent both Import Tuner and Super Street. I ended up with Super Street. And you had other tuners like SP Engineering, Cosworth, Ace Engineering. These are companies that are well known in different facets of motorsports.
I remember the shootout. It was a really big deal back then.
It was great. And here I am, a small facility, Bisi Moto. I just opened up, facility of 2 individuals, and I was pretty much the underdog. But knowing the criteria of the event, I decided to use a naturally aspirated F22 engine. We did fairly well. On regular unleaded petrol, we were able to get to 360 horsepower, which was a significant improvement over my goal of 340. So I was very, very excited about that.
That's huge.
I'm pleased to say that we also eclipsed Cosworth in horsepower per liter in terms of their natural aspirated VQ Nissan engine.
And you're still doing this with a single cam?
Absolutely,
Wow.
single cam. So I was very excited about that. However, of course, the turbocharged application, the turbocharged entrance won.
Yeah.
Out of a party of A2, I think we came in 5th place, but number 1 in natural aspiration, of course. At a SEMA like this in the same year, at the award ceremony, which by the way, AMS won, and AMS, by the way, great company, the owner and proprietor of the facility, great upstanding guy, but one of his employees came up to me, said, hey BC, why did you build this natural aspirated engine? Almost like taking a knife to a gunfight. I mean, it's a high horsepower build here. And I shared with him. The main goal of the power competition was to make the horsepower reliably. Mm-hmm. And the engine I built, you can drive from Los Angeles to New York and back without any qualm. He looked at me like, oh no, I think you built NA because that's all you know. And I told him like, look, turbochargers are very easy. It's very hard to make power with atmospheric pressure alone. Turbocharging is very easy. You guys did very well, but it's easy. He just looked at me and laughed and said, nah, that's all you know, and walked away.
No, I must agree with you there. I mean, I've built a lot of engines, I've tuned a lot of engines, and while saying that building a high horsepower turbocharged engine is easy, it makes it sound a little bit too simple. But it really is a lot easier to make power with a turbocharger than naturally aspirated. Absolutely. And I mean, some of the engines I've been most proud of have been naturally aspirated engines. There's a lot more to the design, there's a lot more to think about. And when everything works out exactly how you calculated, there's a lot more pride and satisfaction that comes from that. So no, I totally agree with you there.
And so I decided at the point in my vexation to reach out to Jonathan Wong, who was editor-in-chief of Superstreet, and said, you know what, here's what this guy said. Let's prove to him that it's easier to, relatively easier to build a turbocharged application with high horsepower. As a matter of fact, I'm going to do a better horsepower per liter than theirs. I'm going to use a D-series single-cam engine. And you know that little bucket wagon I have that is at the shop that is just a parts getter? It was like a white wagon with pink wheels that I put on as a dare for my team. Let me use that and make that, just show people really what we can do. And he was excited. He said we'll do a 2-part build and we'll have an opportunity to share that in the magazine. So we began. I'll let something out I've never shared with anyone in the media, and is this. That engine is pretty much a naturally aspirated engine. It's pretty much my 10-second D-series engine with a turbocharger bolted on top of it. So for the D16 Z6 head, I was able to design a very ideal camshaft profile. And that being said, camshaft, rod applications, dome design, in this case an inverted dome, something that was very, very efficient. And my goal was to really make just 620 horsepower, thereabout, would be ideal to the wheels. It was the first time I also elected Ryan's wiring expertise in that setup. So that's how we initially met, and he wired it up, did his mil spec harness and everything. It was very nice. And I embarked on this journey. On regular gasoline, pump fuel, 91 octane from California, and an AM water meth kit. First time on a dyno, it made 702.
Wow.
At 41 PSI, but it made 702 horsepower. And I looked at my plugs, a little peppered, so I had a little pinging there. So I upgraded to a 100 octane from VP, Street Blaze, once again an unleaded street fuel. Boom, 724. And I was so excited. And this became my most popular, most profitable Honda project. The camshaft I designed, there were so many camshaft shooters out there, and you'll see the Bisi Moto Level 3.6 making 80 horsepower to the wheels on a standard setup at 19 PSI, while other cams are making 30, 20 horsepower. So it's a very good project, and all around the world, people mimicked that project and mimicked the parts I used in it. And you look at any 9-second single-digit single cam in the world, they all use components that came from that build, which is pretty exciting.
Let's just talk a little bit about that. You said you used basically your naturally aspirated build, and that's one of the things that I've found with my own experiments. Once you start talking about a large turbocharger, something where you've got, obviously you're measuring turbine inlet pressure, so that's the back pressure between the exhaust valves and the turbocharger, and you've got your boost pressure in the intake manifold. So on a normal turbocharged road car engine, we might be seeing a ratio of maybe 2 to 1. So that's twice the back pressure in the exhaust than what we're running boost. But when we talk about a serious, a proper sized turbocharger,
Yes.
things go the other way. And our
Absolutely.
back pressure in the exhaust actually gets lower than boost.
That's very true.
When we go like that, the engine actually starts responding like a naturally aspirated engine.
Yes.
And your cam, your head package, everything like that, that's when you start working with an engine that basically is a naturally aspirated engine with a turbo bolted on.
Your experience is on point. It's exactly been my expertise, my observation as well.
Yeah.
Yeah.
So it's all about that turbocharger sizing
Yes.
and getting to that point.
Absolutely.
Okay, so that's one of the cars you're most well known for.
Yes.
These days I can see you've also moved into a number of other cars. You've got Porsche as one of your big brands that you're
Yes.
well known for, and also more recently Hyundai.
Yes.
Can you tell us how you moved into those other brands?
Absolutely. You know, most of the clientele that I have recently with the Hondas are road race individuals or people with high-end drag cars, and most of those people are very successful businessmen. And on the daily, they typically have a Porsche 911 or a Cayenne or something of that nature. And many times they'll ask me, Bisi, you should really build something. You should make something for Porsches, And I've always had affinity for Porsches, even being younger, and decided I'm going to explore that. So my very first Porsche is the blue one with the twin turbos everyone sees online, and it was pretty much in its 1976 body, using a 996 engine, twin turbocharged with a 997 gearbox, and it became my most popular project ever in terms of a European market.
It's pretty well famous all across the internet.
Thank
Was
you.
it 771 horsepower?
Yes, 771, and
Yeah.
she drives beautifully. I enter her in rallies from city to city, a road race with her. It's an amazing power plant and just extremely reliable as well, and a great test bed for me. And everyone pays attention. I took a page from my book of a single cam where, if you do something very unique, everyone pays attention. So the purists, they hate the car, but they pay attention to it. And the hot rodding guys love it. It's just a great balance between form and function. So I'm very excited about her. And with Hyundai, of course, I've had a very good stint with Honda building some excellent project cars for them. Honda's been a great partner for us, and I've built many SEMA cars and many project cars with them. As a matter of fact, this year, we're the only facility in the country that's worked with them in terms of building a project car, working with them directly.
It's a huge honor.
It's a great honor indeed, and people take notice. It gives my company a lot of credibility, and above and beyond that, it gives me access to future technology that's not released to the masses yet,
Sure.
and hence I can really play around with it and develop products in the process. So Hyundai took a note to my success with Honda and approached us, and last year, we built the most powerful front-wheel drive Hyundai in the planet at 602 wheel horsepower, 2013 Elantra GT. And this year, we had the opportunity to partner with them and build the most powerful Hyundai, period, at 1,022 horsepower. And that was a nice Genesis coupe that we built for them. Did some track testing recently, and it was just a blast. So that being said, I'm very honored. We're also, other OEs have come to talks with us. So next year should be a very interesting one indeed. I look forward to great success. It's been a great ride so far.
That's you've got a really interesting story there,
Thank
Bisi, and we love the cars you build. They're top level, they're making huge horsepower, and they're doing it reliably. So really, what more can you ask? Before we move on, we just have 5 questions for you that
no
we're going to
problem.
put to basically everyone, just so our followers can get a little bit more in depth with where you come from. So
Right.
some of these aren't even really that related to cars, but can we start with, what was your first car?
My first car was a Peugeot 504. Peugeot
Yeah.
504. It was a vehicle that my father handed down to me when I was in Nigeria, and I drove that for a bit before I came over to the United States.
Okay. Favorite car that you've owned?
Favorite car I've owned? Favorite, I would say my wagon. It really is, a great mix between technology and old school. So I really like the Civic wagon a lot.
Yeah.
The Shadow is a great car, so it's one of my favorite ones. The most enjoyable car I've had that I've actually put to the test is really my Porsche 911. The blue one is just, the rear-wheel drive, rear engine layout is just a blast to just punch and just, if I don't keep a full tank in it, it wants to lift the wheels up. It's really frightening but enjoyable at the same time.
So it's fair to say that's not a dyno queen.
It's not.
It gets driven hard.
That thing gets beat up quite a bit.
Okay, next question. What's your favorite food?
Let's see. There's a Nigerian pepper soup.
Nigerian?
Yeah,
pepper soup?
Nigerian pepper soup is made of goat meat, and some of my father's laughing in the background. It really is my favorite. I can eat that every day for months at a time.
Oh,
Very spicy.
I'll have
It's
to look it up
fantastic.
when I'm in
No worries.
Nigeria next.
Sounds good.
What do you do to chill out when you're not working on cars?
Unfortunately, I don't have any downtime. I'm
No?
a bit of a workaholic, and my team here can attest to that.
Well, we've seen that coming up to SEMA as well. I don't
Yes.
think you got any sleep last
No.
week.
No, I don't. I really don't have it. I don't watch television. I don't watch the news. I just love technology, and I work quite a bit. So What I've noticed recently is that, me having a new family, young family, I just had a daughter about 11 months ago. My family's been a bit of my break. So in the evenings when I come back from work or certain weekends, maybe in the morning we'll go out for a nice drive, go to breakfast after church. That's been my little leisure time and things to do. But I don't have any pastimes. Racing is fun for me, but it's still pretty much work. And when at work, I'm deep into it.
Okay. And lastly, if you could choose any car and any track in the world, what car would it be and what track would it be?
Any car. It would be, I would like to get my hands on a Veyron, Bugatti Veyron, and do some Bisi Moto magic to it, and take it to the Nürburgring. That would be ideal for me.
Okay.
I really love, looking at that French vehicle, I love the attention to detail. I love the turbocharging system on it with the multiple turbochargers. I love the sound, but there's some raw power, something raw that's needed there that I can provide. So that's what I would, the ultimate for me would be to modify a Bisi Moto modification to a Bugatti Veyron, take it to Nürburgring in Germany and have a blast.
Well, when we've got a production car that's already got 1,000 horsepower, some Bisi Moto magic, I'd love to see what you could produce with a Veyron.
Sounds good.
Look, Bisi, really interesting story.
Thank you.
You've probably got a whole bunch more that you couldn't share with us tonight. I love what you've done. Your engineering background is obviously working out really well for you, and you're producing some amazing cars. Thank you very much for sharing your stories with us tonight.
The best is yet to come. Thank you.
Now we've got a video here that we shot while we were at SEMA. Ryan took us for a bit of a tech tour with a Lexus that he's done a loom on. So we're going to have a look at that now, and when we come back, we'll have a quick chat to Ryan about how that worked out.
Hey guys, it's Andre from the High Performance Academy. We're here with Ryan from Rywire, and we're here to talk about this 2014 Lexus that Ryan's wired for Evasive Motorsport. Now, Ryan, can you start by telling us what's the engine that's in this car now?
Engine in the car is a 2JZ. It's a stroker 3.4 liter actually.
Okay, so when you're doing an engine swap like this and you're wiring for it, there's obviously, you're changing pretty much everything. What ECU are you running?
AEM Infinity on this one. Those guys work with AEM a lot, so they chose AEM for the job.
And what sort of sensors are you using attached to that Infinity?
Lambda sensor from AEM, water temp, manifold pressure, fuel pressure, oil pressure, everything's AEM. So it was easy to just use that in conjunction because they're all the same stuff. So easy protocol and between the two.
When you're wiring a car like this, do you make provision or allowance for the addition of other sensors in the future?
Yeah, on this car we actually did a exhaust back pressure sensor, and it's not hooked up right now, but it probably will be in the future once they kind of get to that point and want to do a little bit more tuning on it.
Is that something you would normally do in most of your wiring, add allowance for additional sensors in case the customer changes their mind or needs additional sensors?
Yeah, we've been starting to do that a lot more. A lot of like expansion and auxiliary connectors just kind of hidden in the harness, easy to extend to, and you could just kind of take like a Deutsch connector and make a run to add some auxiliary stuff, whether it be switches on the inside and maybe pressure sensors on the outside.
Now, it really pays with these mil-spec looms to think ahead, because basically once you've terminated and shrunk that loom, you can't really modify it, correct?
Yep, once the heat shrink is done, it's really hard to go back. Can't really go backward.
Okay, so let's talk a little bit about mil-spec looms. Can you tell us what materials you've chosen for this loom?
Okay, on this car we've done Raycam heat shrink, which is like very kind of like the industry standard right now. We did, to kind of keep prices down, I didn't use all the like Raycam strain relief boots, but we did use adhesive heat shrink, proper wire technique, twisted Tefcell wire. So it's all the really badass stuff, but it's maybe not the highest dollar because we kind of do things with budget allowance, right?
Sure. So to the guys on the street, the products you're using, say the Raycam DR25 sheath, what sort of advantages does that offer in terms of comparison maybe to the expandable braid we also see?
Right, yeah, expandable braid is kind of on the cheaper end. Raycam's really a big step up. Heat, it has a mil spec rating, which kind of like certifies it and like, good for off-road use, for motorsports, for military, because that's really what the mil stands for. So yeah, it's a great loom for that. Heat, oil, everything is just a good barrier against it, so it works really well.
Now I noticed with this car as well, you've got the AEM Infinity mounted out in the engine bay.
Yeah.
When you're making a loom for an engine bay mounted ECU, does that give you any more difficulty, anything else you need to take into account?
Yes, we did like kind of a little bit different technique with this one because the engine or the ECU was going to be in the engine bay. We didn't really have any exposed wires at all. I like a couple steps ahead kind of a thing when building the loom, and made sure that all the Raycam would be fully sealed and all the way up to the plugs, just so it has full heat, advantage on our side, and it looks good. Because if you pop the hood and see wires, you really don't want to see that ever. So.
Sure, so you're talking almost a completely sealed loom on it.
Right, basically a completely sealed loom.
Okay, so we talked about the covering the DR25 you're using. You're also using Tefsel wire. Can you tell us the advantages of the Tefsel wire over maybe your normal automotive hookup wire?
Right. Advantages would be the Tefsel has a really high heat temperature rating, so for resistance on the wire, and if the wire gets hot, it can really take it a lot better. Also, it's easier to work with. It's just cleaner to work with. It goes through the Raycam better. It's one of those things where Tefsel, Raycam, like they just go together. So we really try to keep things complementary to each other, and that really works. So.
With a loom like this, how many feet of wire would you estimate go into it?
It's really hard to say because I didn't count, but maybe like around 500 feet, and alternating sizes of wires too for different things. So.
Sure. And how many man hours go into producing a loom like this?
Well, after installation and everything, I would say a good 20 hours.
It's actually pretty quick.
Yeah, it's pretty quick. I mean, we lay everything out, we draw it out, figure out our sensors and inputs to all the pins and everything, and we just kick cracking on it, twisting, and kind of it's like I do some of it, my employee does some of it, and we just knock it out.
When you're doing a loom and designing this loom from scratch, where you've got nothing to really sort of base it on, obviously an engine swap, it's not a car you're doing all the time. Do you build the loom on the car or do you build it on a bench?
We did both actually. We came to the car and took measurements, built a rough layout of it, came back to the car for more measurements and kind of like a little mock-up, and after that we pretty much had everything that we needed, so it worked out really well. So a little bit of both, yeah.
Cool. All right, thanks for taking the time to chat to us, Ryan. It's a kick-ass looking loom. We really love your work.
Thank you, appreciate it. Thanks,
Hey guys, welcome back to Tuner Life. If you just joined us, this show is brought to you by Link Engine Management. You can check out their brand new range of Link G4 Plus ECUs at linkecu.com. Thanks also to GT Channel for streaming us live. If you are interested in watching the latest and most interesting automotive videos on the internet, go subscribe to GT Channel. If you like what you're seeing here and you want to keep your finger on the pulse, keep up to date with the latest in tuning instruments, tuning products, and the best tuners out there, make sure you subscribe to us. Search YouTube for Learn to Tune. If you're interested in learning more about EFI tuning, check out the High Performance Academy at learntotune.com. Now, we just checked out a video of a 2014 Lexus that Ryan from Rywire wired up, and it takes pretty big balls to go and do an engine swap on a brand new car. This has got a 2JZ engine swap. So, Ryan, thanks for joining us tonight. Let's start, I guess, at the start. So you're well known all around the world for your exploits with mil-spec engine looms.
Thank you, yeah.
Predominantly, I guess, with Hondas. Give us your background. How did you get into engine wiring?
So I went to San Jose State University, and like most people, kind of like BC here, I needed more money. My dad could only help me maybe a couple $100s a month for my rent. I, just kind of took it on myself to try to figure out ways to make more money. And I was really into CRXs, so same. Started doing engine swaps for friends, deciding, well, the hardest part of this is going to be the wiring.
Sure.
And we just kind of started, me and my friends just started putting engines in and trying, figuring out problems and figuring out that, SI harnesses don't work with HFs and all these different little snags that Honda throws at you. So I started doing dual point to multi-point conversions, and that was we normally use DX. They were the cheapest ones, CRXs, and doing engine swaps and stuff. The need for doing the dual point to multi-point, and then adding VTEC for OBD0, B16, all these different things were great groundwork to kind of develop something as far as a product goes, I guess, but also just, they were all necessary in getting
Sure.
the car to run.
So, just to move back a step, you actually didn't do a formal qualification. You're not really trained as basically an auto electrician as
Correct.
such. It's self-taught.
Yeah, I went to school for marketing.
Cool.
I went, let's see, I was at San Jose State, and then I was at Monterey Peninsula College. I went for about 7 years, and it just still never finished. It was one of those, the 7-year plan. And
Yeah.
by the 7th year, I had one class and I failed, and it was just like I talked to my parents about it, and they were like, "Well, follow your dream." You know what I mean? And my dream was to create my own business, and really get like balls deep in the Honda market and doing all these cool things that I really wanted to do.
Let's talk a little bit about that. So I've got two Honda guys on the couch
Right.
here. How did you get involved in the Honda? Why was it the Honda brand that was your thing?
Well, I would say that I was kind of interested in 3 cars. Volkswagen Corrado, which is like really weird, but I kind of liked it at the time. I don't know why.
Sure.
Second was the MR2. Twin turbo is what I was aspiring for. And then,
So we're talking SW20 MR2?
yeah.
Sure. Yep.
And then the 88 to 91 CRX.
Okay.
And those were the 3 cars that I wanted. Like those were like, that, at the time, my budget, I was aspiring to have, well, the MR2 twin turbo was like my, the one. Just wasn't in my price range. So my second in line was the CRX, but because I just still didn't have the money, I ended up with a 87 CRX DX, a red one in not so great condition. And that was kind of my stepping stone into the CRX and the Honda market.
Okay, now just recently you took us along to the Chronicles meet at IBAC Springs, and it was an all-comers event, but let's be honest, it was predominantly Honda. And what we've seen, particularly in the US domestic market, the Honda tuning scene is absolutely massive. It's got a following like no other import brand over here. Why is Honda so popular?
I think because it's a reliable car.
Sure.
It's cost effective to build. The engines are designed very, very well, and they make good power. And I honestly think that the main reason why people like Hondas is because of the VTEC. So it's that kick in the pants kind of a
VTEC kicked in, yo.
Nitrous, kicking kind of like turbo feel.
Yeah.
And that's what people I think really like. So
Okay.
that would be, I always aspired to have a VTEC engine, and that was always my dream in my CRXs and stuff to have, dual cam VTEC or, any kind of variable valve, like the big cam.
Okay. So you're pretty deep in this Honda market, and you're doing some work by the sounds of it for friends, etc. How did that change come about to move into Rywire? Where did Rywire come from?
Well, kind of like I was saying, just through school and me realizing that, like, where am I going to really go with a marketing degree? I mean, I can use marketing to market my products, but like, I don't really want to work for the man, I don't want to work for somebody. I don't want to, you know what I mean? And just the ability to kind of like understand myself and like learn things about myself and my personality and stuff, that I don't want to do that for a living and just work at a marketing agency and push Coca-Cola as a brand name or whatever. So I just decided that enough is enough, and let's continue what I was kind of pioneering and starting. And that was just like making wiring harnesses. And I was actually doing like one dual point to multi-point harness a day. And in college, that was like really good. I mean, you're making like $200 a day or something like that.
That's pretty
just
good.
on the side. Like it takes me, I had it down to like an hour and a half to make a harness.
Oh, wow.
So it was like really cool.
That's
I
pretty
didn't
good
even
money.
have to really work because I was just doing that.
Yep.
And then I'd go to the junkyard and I'd clip plugs and I'd make like an OBD0 VTEC sub harness as like a secondary harness to kind of like add VTEC pressure, knock sensor, whatever. So it worked really well. Just eBaying, dude. eBaying, all about eBay.
eBay's the way?
Yeah, I mean, then it was,
Yeah. So you've obviously come a long way since then, and you're now making these amazing mil-spec looms. How did the move into that type of loom development work out for you? How did you learn those techniques?
Okay, so if you guys are familiar with Danny Tran, DTR headers, he's a Vietnamese guy from San Jose.
Yep.
Okay, his guy Derek kind of was like It's like, hey, we're wiring our new race car. It was like a K series, dry sump, RSX, tube chassis, like NA, like naturally aspirated car. And we want to do like a really nice wiring harness for a K-Pro, Honda K-Pro. And do you know anything about this stuff? And I'm like, well, kind of seen it here and there. I don't really know too much about it. I don't know where to source the materials from. And he goes, well, I mean, I got this, I found like this, I don't remember where they got it, but I got like this Raycam heat shrink. And he's like, yeah, and then I get this like really nice wire. It's like motorsport grade wire. And I'm like, oh, that's cool, whatever. Like automotive grade wire works for me. Like I don't, I'm just like basically merging two harnesses at that point.
Sure.
Splicing stuff, and I had pins here and there for nice connectors, and I was doing it well, but definitely not how it is now. So they kind of like told me about it, and I'm like, okay. So I kind of like, I went there, and they're like, come to our shop, like let me just show you, like, and then they couldn't get the car to run. And it was interesting. They had some kind of a power problem, like power distribution of the ECU wasn't turning on, or I'm not really sure exactly what their issue was. But I was able to kind of look at it with them, and then they're like, hey, check out this. They showed me their wiring harness, and they printed little yellow tags, and they were like, oh, this is like how Motec does it. And all the high-end F1 cars are done like this. And I'm like, okay, just taking notes,
Mm-hmm.
And then Derek was like, oh, here's my resources to buy this and that. And I can print some labels for you if you want. So I kind of like made my first wire loom same way with my CRX. And it was like at a Week Fest show. I was like rushing to get it done. And it was like my gray CRX at the time. And it was a K20R swap. And I just made this harness. And it's one of those things that didn't work first try. I was like,
Sure.
Something stupid, and flipped the wire around. And I'm like, okay. But my ability to diagnose it was like all that mattered. If I, everybody could pride themselves, oh, I do everything first try. Okay, cool. But in reality, you kind of don't.
Nah,
you know what I mean?
Happens.
So but if you're able to diagnose something and be like, you know what, this makes sense. If this makes power to that and that's that, then okay, what if I switch it here and then it works, and you're like, cool. You know what I mean?
Sure, yeah.
So I take pride in that, being able to like diagnose stuff. And Danny told me like, oh, you can't do mil-spec harnesses on these cars, and it was like, but why? It's just wires, and it's just
Sure.
this and that, and I don't know, it just doesn't seem to work. Like we're super smart, and they were, but we can't get it to work. And I'm like, dude, I can get it to work. Like it's not
just wires.
It's just wires.
Yeah.
So got it running. Car drove into the show. Car hit the track, button willow. Like I raced it and everything, and did a lot of circuit stuff, and no drag racing, but circuit road race. And Danny's like, dude, you got to fix this car for us. Like we've been out for like a whole season. Like this is terrible. So I redid some stuff for them, and I got their car running back up and running, and they were like, cool. Like I guess it does work. I guess we can do this.
Yeah.
So that's when I was like, okay, well, I got like a little niche, and it'd be cool to continue on with this, but I'm like, I'm never going to make one of these harnesses again. Like this is just for my car. This is like a specialty thing. And it kind of, people are like, well, I want one. Like, I'm like, okay, fine, for you, I'll make it. And then it became this thing where I'm like, okay, fine, I'll put it on my website, and if you buy it, you can have it, And the prices are higher, and a lot of people don't understand this kind of stuff.
Yeah.
But that's fine. There's a lot of hours going into making like a proper motorsport loom. So
Yeah, they're a time-consuming thing.
I know you make them.
Yeah, a little
Make
bit.
them a little
Definitely not as many as you. And the thing I find, and we've talked about it in the past as well, you can't make a mistake with a mil-spec loom. Once that heat shrink is shrunk down, all the boots are on, you really don't have the opportunity to go back and either add anything or fix anything. So
and when materials are crazy expensive,
exactly, yeah.
And if let's say you have to make let's just say you had to make 2 or 3 to get it right, you could be spending thousands of dollars on something that's like very simple,
Yeah. Okay, so someone comes to you now and says they want a loom built for, let's say, a 2014 Honda Odyssey, something really oddball, something you haven't seen before.
Right.
What goes through your mind? What's the challenges that you face there?
So where I normally break it down and start at is I start at the sensor. So if you think about a wiring harness as just wires and a standalone ECU as just inputs, analog voltage inputs, digital inputs, right? getting one sensor to the ECU for logging, for information, for the engine to be able to run right. So what I do, let's take like a fuel injector as like the most simple form. A high impedance fuel injector has a 12 volt, like you can call it constant, but it's switch power. It's power to the injector, and then it's a ground trigger to the ECU. So what I try to do is I try to think about each sensor that I'm going to use, and a lot of times we'll use aftermarket sensors. And what I'm getting at with this is that let's say that you have the fuel injector and you have the power and the ground. That's the most simple one. They're all pretty much the same. There's no real like variation of that. Power to the ground to the ECU. Now, take it another step. You have something like a map sensor. If you're running like a aftermarket one that matches the ECU maybe, you get a pinout configuration with that sensor. So it tells you, you know, which one is going to be a 5 volt reference, which one is going to be a sensor ground, and which one's going to be the signal. So now if you don't have that information, so let's say that you have, let's say like the Hyundai that I did, the cam sensor, you still need to know which one is going to be power, which one is going to be ground, and which one's going to be signal. Now, you know, sometimes brand new vehicle, the information is not available online. You know, it's kind of harder to achieve. Well, you can kind of like backwards engineer a factory loom, and you can go, okay, well that wire went to the fuse box, and it goes to a 5 amp fuse, so we can pretty much guarantee that this beep, continuity check, okay, that one's power, right? Ground, it goes to a ring terminal that was on the side of the head, okay, that one's power. And then there's another wire that just goes straight to the ECU. You may not even have an ECU configuration for it, but you know that that's going to be the signal wire, right? So that's the first thing that I do. I write a pinout chart of each sensor that I'm going to decide to use. Maybe if there's a cam sensor that we don't need, I'll just disregard it, right?
Sure.
Crankshaft sensor is obviously very important, so I need like things like that. So I write a schematic, and then I figure out what engine management we're using, and I look at that ECU schematic, which is almost always available from any aftermarket ECU. And you can.
So sorry, I'll just stop you there. You don't limit yourself to one particular brand of ECU. Basically, you'll wire whatever anyone brings to you.
Yeah, we've done like a lot of different stuff.
Sure.
And stuff that I don't even, honestly, like sometimes I don't even remember the name of the ECU. I'm like, oh yeah.
As long as you've got the schematic, you're good to go.
Right, exactly. So you know, you see their chart. Sometimes they have really nice drawings. And sometimes they're like, it's a designated input that says like, this is exhaust back pressure. That's where you put the signal wire for exhaust back pressure. Other like systems like a Motec, it's
configurable.
Like, it's configurable.
Yeah.
So then what I found myself doing is I write a schematic for the tuner. You know, if I'm doing setup on myself or whatever, like, you know, just to get the car running, sometimes I do that every now and then, but I'm not the best and I don't consider myself a tuner. Yeah, you know, I make a sheet and I say, this is where I assigned all these, you know, analog voltage inputs and, you know, temperature inputs and everything. So I make a really detailed chart and I enclose that with the wire harness. And hopefully the tuner that they're using knows me and, you know, can contact me if there's any questions. And that's pretty much how we do it. So
one of the questions I guess I've got is getting access to connectors for particularly newer vehicles. It can be quite tricky. So how do you go about that? Is that a challenge for you?
Of course it's a challenge. I think it's a challenge for everybody. Anybody that's ever tried to do that, don't even try it. No, it's not even worth it. It's way too much headache. But no, honestly, like I source connectors wherever I can, man.
Sure.
Like
so it's not just one place.
No, hell no. It's like if I get a lead, if somebody tells me something or gives me like a part number, or if I can like sometimes there's like Yazaki parts that are written on there on the connectors, and you're like, oh shoot, this is cool. I could find it, you know. But there's stuff made in the United States. There's stuff made in China. There's stuff made in Taiwan. There's stuff made in Japan, all over the world, everywhere, Europe, and
so, some of these manufacturers that provide connectors for the OEMs, like AMP, you know, you can't go and deal direct with AMP, can you? Because they'll sell to you, but they want you to buy like 100,000 items, and
if
you're going to buy like 5, and they're just like, no, it's not going to happen.
Yeah. If you're not an OEM, those guys don't want to have anything to do with you. They're looking for a lot of different connectors in completely massive volumes.
Sure.
Enough to build like like, you know, Honda, it gets an account. Okay,
Absolutely.
well, obviously it's like,
Yeah.
they have millions and millions of connectors. But yeah, like it's really a challenge. It's a huge challenge for me. And there's different ways, and I have and that's really what kind of sets me apart,
Yeah.
is that I stock literally hundreds and hundreds of different connectors, ranging from every different manufacturer of connector. And when I find one, I just like, when I first found my like couple main resources to, let's say, start doing Honda looms, I mean, I literally felt like I won the lottery. It was the craziest feeling ever. And it was like, if you ever like, think about it this way, if you were gonna win the lottery, but you don't know how much you won. Like, I won, my numbers showed up, but I don't know how much money I won. You know, that's literally how it felt. Like, okay, I could do so much with this, and then I'll think about it this way, I could make $5 off of this winning the lottery, or I could make infinite, right? So I obviously took it as, it's going to be this is an infinite market, you know.
So you're not gonna share up your trade secrets with us here tonight?
Email me and I'll tell you. No, I'm just kidding.
Okay. Let's talk about the looms that you see come to you that have been done elsewhere. Obviously wiring, and I mean, I'm a tuner, I see a lot of problems with wiring harnesses. It's got to be the number one problem when you're trying to tune a car, and it can be really frustrating. What would be the number one biggest fault that you see with cars that come to you have been wired elsewhere?
Let's see. I would say that improper technique is a huge one. You start like, you're trying to figure out somebody's issue, and you know, you start picking apart, and then you'll see like, oh, I found a tape, like I found a random like taped section.
Sure.
Well, what's under a taped section normally? That's obviously not factory, right?
Yeah.
So there's some kind of a splice, and it may be like a really bad solder, and maybe just an improper termination, you can call it, right? Somebody, you know, randomly, you know, it's a junkyard harness, something's cut, and then they're trying to wire on a different temperature sensor or something like that, and it just gets bad, and it's really easy to kind of catch those, because you're just like looking at like, this is all factory, and all of a sudden it's like, there's something under there. I know there's something under there.
Yeah.
So
those are the kind of keys that you look for when you're trying to fault find someone else's harness.
Exactly. And I'm not trying to throw anybody under the bus by saying that, but I mean, every now and then you get like a DIY kind of a dude comes in and like, you know, hey, you know, I did this, or it may even be my harness, and then they're like sending it back to me like, oh, the temperature sensor's not working, and and I get it back and I'm like, well, they changed the plug to something else, and they
didn't do a good job of it.
very good job of it, and it's you know, the ECU's freaking out now, you know.
Let's talk about crimping versus solder, because that's a big thing.
Yeah.
I mean, OEM harnesses, particularly if you're looking at anything in the aftermarket for pure motorsport applications, solder's really not used a lot. So what are your thoughts on solder versus crimping?
I really try to stay away from anything that has to be soldered. There's ways of soldering things like fairly well that can last a good while.
Yeah.
But let's face it, like why? You know,
Yeah.
if you can crimp something like a factory splice, you know, a factory crimp, and then holds a rubber seal and everything's, you know, kosher, just like OEM, like why not? You know what I mean?
I think a lot of people almost take some satisfaction in the fact a soldered joint seems more safe or more sound, but the reality is it's very susceptible to damage from vibration and from fatigue.
Right. The solder joint normally is like the strongest point,
but it'll fracture at the end of the solder.
Yeah, on either ends where it's not like constant. That's where you see a fatigue, or if like a solder isn't perfect and it's like a little like spiky, and then that'll puncture through and start rubbing on something else.
Yep.
Shorts, and like you be chasing your tail. You know what I mean?
The flip side of that is a properly crimped joint. Basically, that crimped joint is stronger than the parent wire, correct?
Yeah, like on our wire harnesses that we do, we actually test our crimps. So we have a machine that crimps the splice, or you know, crimps the terminal, and then it's pull tested.
Wow.
So OEM strength of a pull test is in a certain range. So let's give it a number of, you know, 50 or whatever, right? So then you want to be right in that OEM range, and the terminals actually they tell you like what they should be crimped to, when they should fail, like when they should literally pull apart, and not meaning pull off the pin, but breaking
the wires.
at the wire.
Yeah.
Normally at the pin side, but
Yep.
it breaks. So yeah, we're all within range on OEM spec stuff. So I mean, really, you shouldn't have that issue.
So really, in your mil-spec harnesses, no need for solder, no call for solder in the middle.
Yeah, I really just try to stay away from that. Sometimes when we're like shielding heavy noise circuits,
Yeah.
like a reference or a sync, wire, sometimes what our kind of like technique is to do a little tiny solder to a metal shielding jacket to pass through like a Canon plug or something
Sure,
like that.
yeah.
But we just use a lot of we were really careful with it when we do it that way.
Yeah. Yeah.
And just really try to not solder as much as possible. Like that's the main thing. Like my soldering iron is literally like $10 from Circuit City or like whatever it is. Fries
Just
or whatever.
doesn't
like
get
I
used.
hardly use it, Like if we have to make an ECU jumper where I'm like soldering to it and I have no other way and it's just like a header plug of an ECU to a different kind of an ECU. Yeah, like if it's a one-off.
you'll
Otherwise
pull
you
the
do
soldering
like
iron
dip
out.
solders and stuff. But yeah, then I got to pull the soldering iron out. But I'm really like, yeah, I don't even have a nice soldering iron. Don't need it. Don't want one.
Let's talk about the way technology is moving. We've got CAN bus, we've got drive-by-wire, we've got variable cam control. Engines are getting more complicated.
Yes.
Direct injection. Your business is based on this technology, and obviously you've got to keep up to play. Let's hear what your concerns are with the future. What worries you?
What worries me the most, I guess, is CAN systems. Like if you look at the cars that we wired for Sema this year, there's like 3 manufacturer cars that we did,
Yep.
right? We did the Honda Odyssey, we did the Hyundai, Genesis Coupe, and then the Lexus, right? The IS 350 with the 2J. Okay, so, excuse me, those all have CAN systems from the factory, right? They're all a lot of things. They're all drive-by-wire, they're all CAN, they're all these, everybody's very streamlined now. But CAN's tricky because every manufacturer has their own CAN protocols. So if you notice, and I'm sure a keen eye would notice right away, that we really don't integrate to the factory CAN system, and we don't really have the ability to yet.
You've kind of dodged a bullet, really, haven't you? You've got away from needing to integrate with that.
So what we try to make is like kind of like an overlay deal. I just call it an overlay, but you can think about it however you want. But engine harness with its own relay pack,
Yep.
and then a display that has its own power and CAN to the aftermarket ECU.
Let's just talk real briefly about that as well, because that's one of the big things. You've got your factory gauge cluster, you've got a speedo, you've got a rev counter, climate control, you've got a fuel gauge. Those sorts of things people don't understand. Actually,
Starter button.
It all works via CAN these days. So even you go and replace your ECU with a standalone, and all of a sudden it's impossible to make that gauge cluster work. Correct?
And it's really hard to convey to my customers that that's how it works.
Yeah.
They're like, well, I just have a Honda Fit, and like I want to do a K swap, and I'm like, well, I can't just make you a patch harness, just a problem solution. Like everything now works, and your cluster works, and your heater controls work, and it's not that easy.
So it's actually getting harder to modify cars, basically.
Yes, they make it very difficult with the newer OBD systems, and like you could just see how many catalytic converters they're using these days, how many lambda or O2 sensors that they're using in all these cars, and it's crazy. Like they're to clean the environment, and I'm all for a clean environment. But I mean, you're taking this, like if somebody wants to build a race car, if somebody wants to build a street car, if somebody wants a just car to look cool, it's like they really got to understand where they're drawing the line of like, okay, I'm building a car and this is for street, and I have a body kit and I have wheel suspension. I want to take it a step further. Well, the newer cars, there's this huge gap.
Sure.
And it's like you really have to either stop here, or you have to go, okay, I'm going to take it to the next level, and I'm going to do a display, and I'm going to get away from all the factory electronics, and it is a dedicated race car at that point. Or you're trying to incorporate things that are serious work, and your bill with me is going to be high, and it's just how it is.
And I mean, people, I guess, need to understand that's the way that cars are going. Things are becoming more complicated, hence that takes more time and more skill from the guy doing the wiring.
Right.
Okay, so that pretty much brings me to the end of what I wanted to talk about here. Now, you've agreed to come on board with High Performance Academy, which we're really grateful for, and we're going to be bringing you a course on wiring fundamentals with Ryan. Ryan's going to be presenting that, so that's something to look forward to. Hopefully we'll have that out to you in the next few months. Before we leave you though, Ryan, let's go over our 5 questions. So can we start with the basics? What was your first car?
My first car, I think I kind of mentioned it before, was a 86 CRX DX.
Yep.
Pretty rough, but it was a starting point carburetor.
So you really started with the brand you wanted to stick with.
Yeah.
You've owned a hell of a lot of cars. We've seen a few of them already. What's the favourite one you've owned?
My favorite car had to be, my white Civic's just like, it's so new, but my favorite car, because it's just like, it stayed with me for a while and I really, really appreciated that car and I learned a lot from it, was my green 88 CRX.
Sure. Yeah, that's a pretty well-known car with the K-swap, yeah?
Yeah, K-swap,
Yeah.
and then it went to a B-swap, and then now it's back to a K-swap with a different owner.
Whoa.
But yeah, it's been all over the place.
Sure.
But that was definitely a huge learning experience for me. I actually crashed a car right before that, and my insurance did me very, very well on that one, and it like got me enough, after I parted out, it got me enough money to basically pay for the K-swap. And without that K-swap CRX, I would not be where I am today. I got a lot of exposure from it, and it like just was a huge stepping stone in my career.
Cool.
So it's a very important car.
Moving a little bit away from cars, favourite food?
Well, I really like Japanese culture, and I love Japanese food, and I really like eel, unagi. It's my favorite.
Nice.
I'll eat it every day. If I could get sponsored by Unagi somehow, I would just like do as much marketing for them as possible.
Yeah, I'm not sure
that's not really possible at all.
I'm not too sure that Eel would agree with you, but fair call.
I know.
What do you do to chill out when you're not working on cars?
Well, what I normally do is go on some kind of a car adventure.
So really, when you're getting away from cars, you're still working on cars?
Tokyo Auto Salon, going to like Honda Day, going to Week Fest car shows, judging there and doing these things. It's like, that's a getaway for me.
Yeah.
I may spend a day at the beach, and I may spend a day doing something like non-car related.
Yeah.
But in the end, it's still like a trip revolving around what my passion is, and that's
it's ingrained in you.
Of course.
Can't get away from it. Okay, and lastly, if you could drive any car on any racetrack, what would it be and where would it be?
Well, I think that a car has to be, it's got to look pretty on the outside. It's got to look great on the inside. You got to be comfortable in the car. And I actually don't even know the name of the car that I really want to drive, but I know the manufacturer, and it's I saw it on Speed Hunters. The new Zonda, I don't know, can't pronounce the name.
That H name car, yeah, I can't.
Dude, the performance, the exterior, the interior is so wild and like high class, and it would just be like a dream to just be sitting in that car, like looking around. I wouldn't even be looking at the road, I'd be looking at like the door panels and the gauge cluster, and everything's like so crazy. Yeah. And if I could take that around like Laguna Seca or something like that would probably be like, I would probably remember that for a really long time.
Yeah, I think Zonda really take things to the next level with their attention to detail.
Yeah, and that's
amazing car.
Really what I like as far as car stuff. It's all about attention to detail, and like that car, really, I think like, if I could do a car like that, like that's, you know what I mean? Like some of my builds and stuff are very attention to detail, as you've seen.
Yeah.
So like that's why I'm focused to a car like that.
Cool.
And obviously it'd never be my budget. Well, maybe one day, but
just got to build a whole bunch more things.
Right.
Yeah.
Exactly.
Okay. Look, Ryan, thank you very much for taking the time to talk to us. Your looms are definitely in a class of their own, and we have a lot of respect for your work. We're looking forward to working with you to produce a course, and I'm sure there's a lot of people out there who are looking forward to. I thought you were going to get naked there. It was real weird.
Well, I'm on the casting couch here, so I figured.
Okay. No, that's good that you were just showing the HPA T-shirt. So we look forward to bringing that to our followers. Okay, so moving along, while we were at SEMA, we caught up with Stefan from Papadakis Racing, and Stefan's a guy I've personally followed for a long time. Again, his exploits initially in drag racing kind of one of the reasons I got into drag racing in the start. He's moved on, he's now involved with Formula D, and he's the car builder and tuner for Frederick Aspo, probably one of the bigger names in Formula D. And we took the chance while we were at Sema to check out Frederick Aspo's Scion TC and get a bit of a tech tour with Stefan Papadakis, so check that out.
Hey, it's Andre from the High Performance Academy, and we're here with Stefan Papadakis from Papadakis Racing, and we've got Frederick Aspo's Scion TC Formula Drift competition car here. Now, Stefan's been nice enough to offer to give us a bit of a technical tour over what makes Frederick's car tick. So, look, this is a pretty serious car. Obviously, all of the cars, Stefan, that are running in Formula Drift these days are fairly heavily modified compared to anything you'd buy off the showroom floor. Let's talk a little bit for a start about the conversion from front-wheel drive to rear-wheel drive. How much involved with chassis modification was there?
Sure. Well, first of all, Formula Drift, the series, has very strict rules on what we can and can't modify. So it's a very factory-based chassis. So they allow us to cut a certain amount of inches away from the firewall and from the floor just for fitting the bell housing and the transmission. So we do that. We build a new little area of the firewall and tunnel and custom engine mounts, and we have to notch the front cross member a little bit.
It looks like it's going to make it a lot easier to work on, though, with the way the engine bay is laid out. Is it pretty easy to get an engine in and out?
It is. Well, so the front-wheel drive cars have pretty wide frame rails because the engine usually is, across the engine bay. So when you go to a longitudinal setup like what we have, it's very wide on either side, easy to work on.
Is there anything you have to do when you're building these chassis that you're sort of keeping in mind to make them easier to repair? Let's be honest, they spend a lot of time rubbing the guardrails these days.
Sure. We cut everything off that Formula Drift lets us cut off. So we can't modify anything inside of the front and rear suspension points. So if you look at the car, you'll see right where the front suspension points are, it's basically the front chassis has been cut off and we have like a tube chassis up there. And that makes it so the car's a little bit more robust if it does run into something, and it's easier for us to fix. It doesn't have to go to a body shop. We can just build some new tubes at the shop or even bring spares with us to the track.
Yeah, it sounds like that'll make it a lot easier to work on. Now, that engine, you said that you're making somewhere sort of around 700 to 800 horsepower. You're running a large turbo and a shot of nitrous. Tell us what you had to do to that engine to keep it reliable and hold it together at that sort of power level.
Sure. The 2AR engine is actually quite strong from the factory as far as the bottom end. We use the 2.7 liter crank out of a 1AR, and that's been reground for a little bit different, like traditional rod bearing, a 2-inch rod bearing. We use a forged rod and a JE piston, and actually a stock sleeve. We had to keep the head on. We upsized to a half-inch head stud, so it's a larger diameter head stud, and factory head gasket. It's a very good 3-layer stainless, and it's got the 1 layer where it adds like 3 thousandths more seal just around the top of the cylinders. It's pretty common on a lot of the new cars. The big weak point in the engine is the valve train. So above 6,500 RPM, the hydraulic lifter and there's little lash caps that are on top of each one of the valves. The hydraulic lifters fail, and rocker arms fall off and lash caps fall off, and it creates mayhem. So we actually use a racing valve train that's a solid lifter, and we upsize, instead of the 5.5 millimeter valve, we run a 6 millimeter valve and a racing roller rocker that cups the valve a lot more. So even if there is some float, the rocker doesn't want to actually fall off.
Is the stuff you've done with the valve train all in-house that you've developed, or are there off-the-shelf parts available for these engines now?
They're semi-custom. What's pretty good for us is the GM Ecotec engine that they drag raced for years has a really, really similar valve train. So we actually are able to use the rocker arms and the solid lifters that they originally developed for those Ecotec race engines, and we do a custom SuperTech valve and spring kit for our engine, and we end up with a really reliable system.
Great that you got to the bottom of the problem. Now, you mentioned that you were using a 2.7 litre crankshaft that was offset ground. What's the actual capacity of the finished engine?
It's 2.7 liters. We use the factory bore size because we want to keep as thick of a cylinder wall as possible. And I think it's, don't quote me on this, I think it's 106 millimeter stroke maybe.
Okay, so as for getting some boost into the engine, what are you running there for a turbocharger?
We're running the EFR from Borg Warner. It's an 8374 turbocharger, and it's all ball bearing, and I mean, this thing's been super reliable. We run these for 3 years and never have failures. We send them back every 6 months, so the engineers at Borg Warner can look at them and see what kind of wear they have, and they're like, we just put it right back together and send it back. So we've been extremely happy with the Borg Warner product.
Perfect. I did notice with the EFR series they've got an option for an internal wastegate, and you've got 2 external wastegates on this particular car. Is there a reason why you've gone that way?
Yeah, so initially we started with the internal gate because it was much simpler, but sometimes we'll run a very wide range in boost, low of 12 psi and very high of 30. The internal gate is not able to get us both of those. If we try to put a gate on there that can do as low as 12 psi, when we try to turn it up to 30 psi, the back pressure actually opens up the valve. So we went to the twin wastegate setup because it's the tangential exhaust housing, which means it has 2 routes into the exhaust housing. So we have a wastegate for each one of those routes, and now we can have dead nuts regulation wherever we want.
Yeah, that makes sense. Okay, so as for the rest of the engine, what about the fuel system and the nitrous system? Can you tell us how that works?
Sure. We run on an E85 fuel, so it's mostly ethanol, and we run 2 Bosch 044 pumps in the tank. That goes to a Dash 8 fuel line up to the front, and just 4 Injector Dynamics 2000cc injectors. And through those injectors, the AEM Infinity controls not only the fuel that we normally run on the turbo boost, but also the fuel for the nitrous. So when the nitrous is active, the direct port nitrous system shoots nitrous into the 4-cylinder ports, and the additional fuel for that comes through our normal 4 injectors controlled by the Infinity.
So it's a dry system, and you're using the Infinity to supply the additional fuel.
Exactly, and that way it's always consistent, and we monitor the fuel pressures and everything and make sure that we always have enough fuel pump, and once we get past that initial development phase, then it's solid after that.
Okay, let's talk about the electronics package in the car. You've got the AEM ECU. I notice you've also got a dash in there. Are you doing data logging through the dash?
Nope, the AIM dash we have is just for display. The AEM Infinity, we do most of the data log because mostly what we're looking at is the engine parameters, and they're already going to the Infinity. We also have the AEM AQ1, which is like a chassis data logger. And when we do suspension testing, we'll have linear sensors on the shocks, and we'll run those into the AQ1. But we don't use that most of the time during the weekends. That'll just be some initial testing or if we're doing component design.
I'm guessing you've got enough on your plate with a competition weekend than worrying about shock travel sensors.
Yeah, it's this drifting is so much about the driver, and it's so much about these guys just really being in tune and driving really well. We just need to give the drivers a really good solid car. That's their tool, and then they go out there and put on that show and do a really good job in competition.
All right, before we finish up, I just want to talk a little bit about the drivetrain. So, I mean, the engine's making a lot of power. I've seen how these guys drive. They're absolute animals. So how do you hold a drivetrain together on this sort of car? What sort of clutch and gearbox are you running?
Sure. So ACT builds us a custom triple disc clutch, and that's the one that we run. The transmission is actually a NASCAR spec G-Force racing. They call it a GSR transmission. So it's a 4-speed. It's a dog box, straight cut gears, and the ratios are pretty straightforward. We mostly do our tuning with the rear end gear ratios, depending on track layouts.
So tell us how you go about choosing your rear end ratio from your data from the track.
Sure. So we want to make sure that Frederick can stay pretty much floored in the high speed parts of the track. And if we see that the car is sitting on the rev limiter a lot, we'll usually put a little bit longer gear in the car. Or if he's having trouble getting it up to the RPM that he needs and maybe it's part of the slower part of the track, then we'll put a little bit more ratio in it.
And do you have to change the whole rear end, or are you just changing the ratio?
we changed the whole rear end. The rear ends that we use are actually out of like a 94 Toyota Supra, a JZ80. So we have several rear ends with a couple different ratios. Normally we run a 4.27 ratio, but we also put in the 3.7 sometimes.
I'm guessing with the tube frame rear end and all the modifications, those sort of changes are pretty quick at the track anyway.
Yeah, the guys will get it changed in 35 minutes or so. It's usually pretty hot when they do it, but it's relatively quick. Yeah.
Hey, look, thank you very much for taking the time to show us around the car. It's an awesome work of art. The engineering is second to none. Now, Frederick came fourth in the championship this year. He's got a bit of time in the off season. Hope you guys do really well next year, and all the best.
Thank you very much.
Thanks for joining us, guys. So you've just seen Frederick Asbo's Scion TC. I'd like to thank Stefan from Papadakis Racing for giving us the tech tour of that car. It's really amazing to see what goes into a top-level Formula D car. Now, you're back with us here. If you've just joined us, you're here with Andre from the High Performance Academy, and you're watching Tuner Life. Today's show is brought to you by Link Engine Management. Now, you can check out their latest range of ECUs, their latest G4 Plus range at linkecu.com. We're powered by GT Channel. If you want to check out all the latest, coolest automotive videos on the internet, subscribe to their channel. If you like what you see here and you want to keep your finger on the pulse, keep up to date with the latest from the tuning industry, make sure you subscribe to us too. Check out Learn to Tune on YouTube. And if you want to learn more about EFI tuning, look up the High Performance Academy, go to learntotune.com. Now, we've come to the end of our segment and we're going to talk to Ryan here about a few of the questions that have come through. Unfortunately, BC from Bisi Moto had a prior engagement, so he's had to leave us. So we're going to look at a few of the questions that have come through from our audience. So first of all, Ryan, we've got a question here. When wiring the Bisi Moto 1000 horsepower Turbo Odyssey harness, were you able to eliminate the stock ECU entirely while retaining the factory gauge cluster? And if so, how did you do that?
Right. It's a really good question. As I kind of mentioned before, we actually did not integrate the factory gauge cluster. Not saying that it can't be done. It can be done. Given the time frame, given the a lot of different things, we were in a rush and whatnot, but there's a lot that goes into that. And CAN systems are interesting things because they differ per manufacturer in most cases, and maybe even more complex than that. But somebody that's really good at computers and understanding code and breaking down certain things, CAN systems can be deciphered, and CAN protocols can be kind of, well, at this point, I would almost, in my mind, I think of it as like hacking into it. You know what I mean?
Yeah, it kind of is.
So it's all doable, but given that particular car we just used in this case, it was a race pack display, and that was CAN, but it was to an AEM Infinity EMS. So the aftermarket kind of goes with the aftermarket. Factory and aftermarket is kind of a touchy, very intricate subject at this point.
And that leads me to another question, because CAN bus is becoming a serious pain in the ass for us in the aftermarket,
Yeah.
let's be honest. And for those of those people out there who don't understand what CAN bus is, it's a two-wire communications bus that runs through the car, and that'll talk to all of the electronics in the car.
Yeah.
So in the old days, we only had an ECU and it was just talking to the engine. These days, we might have 5 or 6 ECUs. You've got traction
you have a
control,
body control
modules, body control
Yeah.
modules, ABS, you've got the gauge
Gears.
cluster, and they kind of all talk together. So to eliminate wires, basically the manufacturers have just put all of this data over a 2-wire bus.
Right.
Called
It's taking
CAN.
the wire loom and
Yeah.
making it more manageable.
So that CAN, that stands for Controller Area Network. Now the problem for us in the aftermarket, and I mean as a tuner I have this issue as well, is all of the manufacturers have their own protocols or addresses for where that data is sent on the CAN bus. And I mean, you can send a huge amount of data over that CAN bus as well. So while for BC's Odyssey, you didn't break that down, you just went with a simple and understandable solution.
Right.
The AEM Infinity can in fact replicate that CAN bus, and
Yeah.
if you wanted to sit there using a canalizer and find out what information was sent over what CAN address,
Yeah.
you
and
could
what,
actually
what each thing is called,
Yeah.
you know, that goes through the CAN.
you could actually program that AEM Infinity to
could.
replicate that, and hence you could keep the gauge cluster. It is all possible.
Right. It's all possible.
The problem is for a one-off like BC's car, particularly with a tight time frame, that's not entirely practical.
Yeah, exactly.
If you are lining yourself up to do a range of maybe 10 or 15 turbocharged Honda Odyssey
Yeah.
2014 wagons.
Or there was like a racing division series
Yeah.
overseas that, you know, they, or here in the United States, and they wanted to, like, you know, they came to us and they were
Yeah.
like, then we would, you know, I'd use whatever info I know, and I have taken CAN bus classes before in the past, but I'd probably get with somebody that really knows CAN protocols very, very well,
Yeah.
and really try to, like, it's almost like a backwards engineering.
Yeah,
To
totally.
figure out what they call TPS and what they call speed and all the info that's on that 2-wire stream.
Yeah.
How to break it down and how to decipher it all.
And then reprogram it back into the AEM.
Right.
So basically what we're saying is we're going to campaign the manufacturers to bring in a Honda Odyssey van, turbocharged Honda Odyssey, 1,000 horsepower van, racing class.
Right.
And
Sure.
we're going to see 15
With-
or 20
with air
of those out there
suspension
with air
and
suspension.
And kids in the back.
And kids in the back,
Yeah.
and you'll be good to go
Exactly.
with the canvas. Great. That sounds really good. I look forward to seeing that because it sounds dangerous.
Get right on that, yeah.
Okay, next we've got a question here about concentric twisting and the importance of harness construction in motorsport wiring. Now, concentric twisting, it's a technique that's it's certainly been a pain in my butt. It's time consuming, it's difficult, it's frustrating, and it's kind of almost a bit of a buzzword. So give us your take on it.
Well, we do concentric twisting here and there. When I have a very, very high-end job that you know, requires the most upper echelon of technique, longevity, quality in every way, we do concentrically twisted looms. It's a crazy process of, you know, a connector of a Canon plug and, you know, taking wires and folding them one way and folding them back the other way in a series of like 7 wires, and it's very, very confusing and very difficult to kind of, you have to really, you have to almost be able to visualize the entire wire harness before you even start construction, where the center one should be the longest so it can break out evenly and you're not pulling things out, and you want it to just very almost effortlessly branch off, and it's wild. I mean, if somebody's really good at it, I mean, they get a lot of props in my book. We normally just do twisted wire, and that gives a very nice, you know, a lot of play and a very agile harness. I don't think that it's always necessary to do a concentrically twisted harness. Sometimes, I mean, somebody may argue with me and say, oh, well, you know, this and that, but for my market and for, you know, we don't have failures and everything still works great. A lot of flexibility, a lot of, you know, able to service later. We do it when we have to, you know, when it's a really high-paying job. Or
For those out there who don't understand what we're talking about when we say concentric twisting, so we're talking about a technique where we have multiple layers of wires, and each layer of wires is twisted in opposite directions. So the advantage with that is we've got a loom that is ultimately very flexible.
extremely flexible, yeah.
We've got a loom that also places no more stress on any one wire, so the stress is reduced.
Yep.
And let's be honest, it looks badass.
Yeah, it looks badass.
But you're going to pay accordingly because it's a very, very time-consuming process. I mean, I've been through it myself. You really have, as you say, you have to be able to visualize the loom. It's a lot of planning in it, and you've got to go back and figure out right from the last connection that you're going to terminate and work your way back. So you're laying that loom up in the right order. So it's no good if the last connection, the longest connection in your loom is on the outside layer of your concentric twist. You're screwed. You can't do it like that.
it's a lot more than twice as long, honestly, of a building process. It's wild. Like it's a lot of forward thinking and forethought.
So let's be honest, for the 90% odd guy at home with their Honda or their street car or whatever it is, chances are probably not a technique they're going to need to worry about.
A twisted harness with service loops is like badass. Like that's
perfect. Yeah.
That's really all. Like I mean, even on my Honda Civic that we just built, and I did auto sport, and everything's super nice, and I have strain relief boots on everything, and it's just a twisted harness with service looped, and it's badass. It's perfect. It's all I need.
Yeah. So if someone's coming to you and they want to compete in Le Mans, maybe they've got a Le Mans LMP1 prototype car.
Right.
Concentric twist, that's the way they're going to go.
Yeah, definitely. That's a badass way to do it.
Okay. While we were just talking there, you mentioned strain relief and service loops. So again, probably a lot of people listening here won't understand what that means. Can you just briefly tell us what that means?
Okay, so let's say at an end of a connector where it's the highest point of stress on the wire, if you add a loop before, you can almost think about it as this accordion of flex. So if somebody kind of mistreats a harness and it's not properly just snapped into place and perfect, and they're maybe pulling on it a little bit, it allows the wire to not pull out. The second thing that it allows is if you do have to go inside the harness and you have to cut that boot off, a lot of times you can slide another one over the top. Well, you can get in there and you got a little bit more room for flexibility, and you can maybe make a splice or something. If you have an issue with a harness, you're adding something, or just any kind of service.
It really comes back to what we were talking about earlier on, where basically once you've sealed up one of those mil-spec looms, there's no coming back from that.
It's like your last ditch, oh my God, something happened, something needs to go inside it. Well, you can go in right there and kind of maybe, hopefully, be able to still have a perfect harness when you're done with it.
Yeah, no, cool. Okay, so we've talked about CAN bus, we've talked about concentric twisting. Now, you're involved with a lot of engine swaps, and
a lot of it.
And that's a big thing, particularly in the Honda market. We've got the K swaps, we've got the B series swaps. How do you account for that? Because I know you've got a lot of off-the-shelf looms for just about every chassis. How do you manage to do that?
So what we decided to develop was an engine harness. You can think about it this way. Let's say you have a 96 Integra Type R engine. Don't matter what kind of car you got 96 ITR engine, B series, let's say. So you have I have a wire harness with OBD2, in this case, 96 to 2000 harness plugs, and then ECU plugs. And it's just an engine harness, they're all the same, okay? And then what we have is a connector that would branch out, and then we would have a proprietary chassis adapter. So in not just the Honda market, in literally everything, you can think about it as an engine harness for the engine, and then an adapter harness that goes to whatever chassis. So, I mean, in theory, let's just be very theoretical here. You buy one of my SR20 wiring harnesses, right? SR20, cool. And then the chassis adapter, what if you specified it for an 88 Honda CRX, right? In theory, it would work because the way that we design our harnesses is engine harness, and then we have a predetermined chassis adapter plug. That plug goes and integrates into the chassis where possible.
So we're talking things into that chassis harness power supplies, earths perhaps, and things maybe we're talking about communications to the dash like an RPM.
Yep. Exactly. Okay. Tach, speed, oil pressure, stuff like that, power to the ECU, coil power, starter power. And where you don't need an external relay, it's the chassis already has a starter relay. So you could take your starter wire, and instead of making your own relay for it, you just figure out where it gets into the OEM, and you utilize it right there.
So really, you've broken down what a lot of people look at as a really complicated system, and you've just simplified it and made it universal.
Yeah, it's definitely a different way of thinking. We kind of think about it as a different way, where people may be overwhelmed with it, but we were okay, well, we build an engine harness to the ECU, and then whatever we're left with goes out. And then whatever we're left with that's going out needs to get into the chassis. And sometimes a fuel pump is controlled by a high side or a low side change, like power or ground activated. So then maybe you're best off just putting a fuel pump relay in that like chassis adapter and kind of getting around it that way.
Yeah.
Or you can have the customer, change something, or you know what I mean. So there's ways of doing
workarounds.
There's workarounds, and for the most part, that's the way we design it.
Okay, I've got a couple of questions for my own interest as well, and it's an area I know you've had a little bit of involvement with recently. Modern engines now coming out, direct injection is kind of, you can see it's going to be the way of the future.
Of course.
We've got a lot of cars now, modern cars with direct injection, goes away from port injection. We're struggling a little bit in the aftermarket because there's a limited number of ECUs, and generally they're very expensive that can control that direct injection. How are you finding that in the aftermarket? What are your thoughts on the system? Is DI going to be a good thing? Is it the way of the future, or are we always going to be port injection?
Well, it's early on in technology for that kind of stuff, so a lot of the stuff has been just converted to port.
Sure.
Or some of the cars are port and direct, so then you just upgrade the port injectors and don't use the direct injectors.
Yep.
Direct injection is a high pressure fuel injector that is directly injected into the combustion chamber. And that's a high heat, high combustion zone, so they have specialty injectors. Now, from what I understand and what I've seen is that different manufacturers use different body sizes, and everything's very proprietary to the engine they're developing. So even like, let's say Toyota has a direct injector, well, they're not going to have that same direct injector for every single Toyota.
It seems like they haven't really standardized.
There's no standardization.
Like what we've seen happen with port injectors.
Right, so then that leaves a very strange place where you go, oh, FRSs are really, really popular. Maybe somebody will develop a direct injector, an upgraded direct injector, but then they have to do it just for the FRS, and then it's got to be in this size, this size, this size, this size. And I mean, maybe there's a market there for something like that, but
we're talking maybe 5 years down the track.
Yeah,
perhaps.
eventually, or maybe in 2016 they'll be like, okay, now we're just going to standardize all direct injectors.
It's going to be this, and we're going to go with it.
Yeah, make it like take that injector, same sizing or whatever, and then create the engine or like develop the engine around it, which they could easily do, but just no standardization just kind of kills it.
Sure. I'm sure that technology will mature, and we'll see a standardization come out of it in time to come. And the last thing I wanted to talk to you about was your own personal, your new Civic that you've got. Well, it's not really new, it's the...
Very old, but...
What is it, we're talking 86, 87?
It's an 86 SI imported from Japan.
Sure. Right-hand drive as well, which is pretty uncommon here.
Yeah.
So you've got a B18C in that car, which again is an engine swap, which you're obviously well familiar with.
Right.
The thing that caught my attention with it was you've got a set of ITBs on the car.
Right.
And really unusual for that combination is I saw you've got a drive-by-wire throttle body, or throttle mechanism on that. Can you tell me why you went that way? Because it looked like it was a lot of work to do that conversion.
It was a lot of work, and it was one of those things where if you're not doing something different, you're not learning and you're not bettering yourself.
Sure.
So I kind of had the idea. The first thing that came to me was, wow, this engine is really everything in this engine bay is very clean, and wouldn't it be amazing to just not have the throttle? Because I mean, I have a hanging pedal system, so you don't see the brakes, and there's like nothing in there, and it's
you've got that totally tucked engine bay.
It's tucked, right? Like
there isn't
the famous word,
there.
tucked. So I was like, you know what? If we took this a step further, and we somehow were able to like not have the throttle cable, that would be like amazing, right?
Sure.
And I work really closely with AEM, and we do a lot of drive-by-wire cars now, like a lot with Motec and AEM. With the Infinity EMS coming out, it can control dual drive-by-wire and all this crazy cool stuff. So I was like, you know what? I got that technology at my fingertips. Let's use it. And the hardest part was to be able to figure out now, how am I going to make this servo drive-by-wire potentiometer work with individual throttles?
Yeah.
And I could get really detailed into it, but I was able to just basically find a throttle body that spun the correct direction to the direction that the rod on the bottom of my individual throttle bodies was moving in, and I was able to just kind of retrofit it on and calibrate it to work.
Yeah.
So it was a very interesting task, and I'm so happy that I was able to do it because it kind of sets it apart, you know?
Yeah, definitely. Yeah.
And honestly, drive-by-wire is technology that is going to be, a lot of people are really scared, oh, how does it feel? Is it laggy? Well, that's kind of, dare I say, it's just really ignorant to assume that it's going to be.
I think back in the early days of drive-by-wire, that might have been,
Right.
you know, a thing. But
Yeah.
These days, you know, the technology's matured, and again,
It's fully programmable. You can have it
yeah.
as sensitive as you want it to be.
One of the advantages I particularly like with drive-by-wire is you could have the potential for 2 settings. So you
Yep.
could have a really aggressive setting, which is 1-to-1.
Yep.
And you could also have a nice dulled down setting, which would be ideal maybe for a wet track. And that would smooth out the power delivery, make the car a lot more drivable. And those are the things you can't really do with a normal cable throttle. So there's definitely some big advantages.
Idle control is a huge advantage.
Exactly.
It's just the ability to just really be able to dial in that idle control and not having like a potential boost leak with an idle valves are, you know, very common a boost leak problem for a lot of guys. So it stays away from that. Also, the traction control abilities with that is awesome.
Yep.
If you could take like your front and wheel speeds, and you know, it's a lot of tuning and a lot of work, but
yeah, we can close down the throttle body when there is a
when
wheel
it's
speed
making too
difference.
much power.
And I mean, the other thing I suppose we can look at is with sequential gearboxes, you can use a throttle blip on the downshift, and the driver doesn't even need to touch the clutch, doesn't need to touch the throttle.
I was explaining that to some of my friends, and they were like, "Oh my god!" Like the BMW M5 was the first car that I was in where it would like manually blip the downshifts for you.
Yeah.
And like that technology is all completely doable and super badass.
So
I mean, like,
it's a pretty exciting time for engine management, and I mean, I think there's a lot of the technologies that we're seeing now, and they'll really flourish in the next few years. And it's only going to make our lives easier in the aftermarket. We're going to have more features. We're not going to be paying any more money for them, and we're going to have cars that drive better, make more power, and put it all to the ground. So that's a win-win. Hey, look, thank you very much, Ryan, for your time again with Tuna Chat. You've been a really great guest along here, and really interesting stories. So thank you very much. So that concludes our first Tuna Life show here from Vegas at SEMA Live, and we'd like to thank you all for coming along and watching. We'd like to thank Link Engine Management again for being our sponsor for this evening's show. Again, if you want to check out their new G4 Plus range of ECUs, please head along to linkecu.com and you can check out all of their products. Again, we'd also like to thank GT Channel for supporting us and getting us out there. If you want to check out the latest and coolest videos on the automotive scene out on YouTube, go and subscribe to their channel. Also, we'd love it if you'd subscribe to us and check out all of the stuff that we're doing in the tuner industry. So go along and search for Learn to Tune on YouTube. And lastly, if you're interested in learning more about EFI tuning, more about wiring, head to High Performance Academy at learntotune.com and check us out there. We'll be coming to you live again tomorrow, so we'd love to have you back. Thanks for coming.
For online tuning courses, visit learntotune.com. For online tuning courses, visit learntotune.com.